I have two animations to show you here. They each show an object, this black dot, as it moves along a curved blue path. This first one shows the position vector r and the velocity vector v. Let me play this and then we'll talk about what each of these vectors is showing us. The position vector r always goes from the origin to the object's location. And notice as the movie plays that the position vector traces out the object's path. It tells you the x and y location of the object. The velocity vector is the time derivative of the position vector. It shows you how that r vector is changing. And it gives you two bits of information. It tells you how fast the object's traveling and what direction it's traveling in. The object's speed is shown by the length of the velocity vector. Let me back this animation up. So we're over here. At that point, the object is moving relatively fast. The velocity vector is long. If I move it forward, we come to a place where the object is moving slowly. The velocity vector is short right here, so it's moving slowly. And then, as we go forward, it speeds up again. So let me play this animation and we can watch the length of the velocity vector. The longer it is, the faster the object's moving. So it's slowing down now, getting shorter. Now it's moving slowly. Now it's speeding back up. The other bit of information that the velocity vector gives you is the direction of travel. As I play this, notice that the velocity vector is always tangent to the path. That's a property that's always true of the velocity vector. It's always tangent to the object's path. Let me freeze this at a couple of spots. If I first go over here, the tangent direction is right here, the line tangent to the blue curve, and that's the direction the object's moving in at that time. If we go ahead, at this spot, the tangent is this way, and that's the direction of travel. And a little farther on, the tangent's in this direction. So we see the direction that the object is traveling in from this velocity vector. Two bits of information in the velocity vector. How fast the object's going and what direction it's traveling in. Here it is again, so we can watch those vectors. Alright, now let me show you one more animation that also includes the acceleration vector. This is the same object traveling the same path. I've just included this purple acceleration vector. The acceleration vector also gives you two bits of information. It tells you whether the object is speeding up or slowing down, and whether or not it's turning. Those two bits of information are best seen by looking at the components of the acceleration vector parallel and perpendicular to the velocity. Let me draw those for you here. The component of acceleration parallel to the velocity, I'll draw here in orange. It looks like this. And it tells me that at this instant, the object is speeding up. There's a component of acceleration in the same direction as velocity. So the velocity is going to change in this direction and speed up. The component of acceleration perpendicular to velocity tells you how the object is turning. In this case, that component looks like this green arrow. Notice that the green arrow is perpendicular to the velocity, so it won't change the speed at all, but it will make it turn. This green arrow will push the velocity vector this way and make it turn to the right. So those are the two things that the acceleration vector shows you: speeding up or slowing down, and turning. Let me erase these. We'll play this animation and look at the acceleration vector at a couple of other points. Okay, so watch the acceleration vector as this animation plays. In the beginning, you should see that the object is slowing down. Let me pause it here. Slowing down because the component of acceleration parallel to the velocity is actually anti-parallel. It goes back this way. so it's going to be slowing the velocity vector down. When the acceleration vector has a component opposite the velocity, it's slowing down. And there's that perpendicular component that will make it turn right. Now later in the animation, about right here, the velocity vector is perpendicular to the acceleration. This is perpendicular to that. So there's no change in speed here. The object is only turning at this point. It's turning to the right, but not changing speed at all. And then it starts to speed up again when the acceleration has a component parallel to the velocity. I'll play this another time so we can watch it again. And once more, slowing down and turning right, just turning to the right, and now speeding up and turning to the right. Okay, hopefully these animations give you a bit of a feel for what these three vectors are: position, velocity, and acceleration, and what they show us about the object's motion.